Okay guys, in this video we're going to be taking a look at how we can very easily sum up, say, the first n terms of some arithmetic sequence. And so I know that my formatting here and my font doesn't look very desirable, but if I were to rewrite what this says, I suppose the idea would be that if we had some arithmetic sequence and it was adding the terms together, and so we would refer to this as a series, suppose if we wanted to add up the first n terms here, this would be considered to be the sum of the first n terms. And so the sum of the first n terms can really be expressed this way, recall, where we have some rule, ai, where I is starting at 1 and going up to n. And so if we wanted to add up the first n terms, the very first thing I want to acknowledge here is we tend to write this with series, or at least arithmetic series and geometric series, as capital S sub n. And what this is going to represent is the sum of the first n terms of this sequence. And so when we talk about arithmetic series, which is the sum of the terms of a sequence, we have a rule that allows us to find the sum of the first n terms, which we write as S sub n, of some arithmetic sequence. And it is this rule that you see here. Now again, my formatting is really poor, so I'm going to rewrite this again with you here. You should have the proper formatting, but the sum of the first n terms is always going to be equal to n times this value here, a1 plus an over 2. And so to put this into perspective, what I want you to consider is this. N, remember, is the number of terms that we have. And when we write a1 plus an, what we're really saying is take the value of the first term plus the value of the second term and divide by 2. And so what this really is the number of terms, and it's being multiplied by the average of the first and last term. So average of the first and last terms. And so it's kind of a really cool fact that if you have something that's arithmetic, it's going up or down by the same amount between terms every time, what we could do is we could simply just take the first and the last term and average them together, and then take it times however many terms there were, and this should work out for us here. And so I just want to take a look at a couple of examples of where we would maybe want to do something like this. And so we're going to take a look at these two examples. It says find the following series. Remember, series is the sum of the terms of a sequence. So it says find the sum of the first 10 terms of this arithmetic series here. So we have a sequence 3, 13, 23, 33. We can see that it's definitely arithmetic and that it's going up by 10 every time here. And so if we want to find the sum of the first 10 terms, I think the first thing I want to do is this. I want to write S10. And so what we're acknowledging is this is the sum of the first 10 terms here. Now with respect to finding this, there are three things that I'm going to want to know. I'm going to want to know n, I'm going to want to know a1, and I'm going to need to know an. And an in this case is always going to represent the last term in that series. And so in this case our n is 10. So when we write this out, I think that I want to start with this. We're going to say off on the side there are 10 terms. The value of the first term is 3, and the value of the 10th term we don't quite know. So here's where writing rules comes in real handy. If I wanted the value of the 10th term, what I could do is I could write out 10 terms, or one thing we could do is just find the rule for the nth term and then plug in 10 to find its value. So that's the route I'm going to take here. I'm going to say that the rule for the nth term is the value of our first term plus the common difference times n minus 1. And we've seen where if we simplify this, we get 3 plus 10n minus 10 we can distribute. And so we would say, generally speaking, the value of the nth term is 10n minus 7. So going back to what I need over here, I need the value of the 10th term. The value of the 10th term would be 10 times 10 minus 7, which is 100 minus 7, or 93. So I'm going to put that back over here as 93. So now, with all of these values, let's go ahead and write our sum using this rule. The rule is the number of terms, 10, times the average of the first and the last term. So our first term had a value of 3. Our 10th term, or last term in this series, had a value of 93. So to evaluate this now, we would just go ahead and simplify. I'd start with 93 plus 3 over 2. That's 96 over 2. And 96 over 2, I suppose we could cross reduce these here and make this a 5. Same as 5 times 96. So I think 450 plus another 30 there would give us 480. But this would represent what we would get if we were to add up the first 10 terms of this series right here. Now I want to try this one more time. Except for this time, it says find the sum of the first 25 terms of the arithmetic series. And our first term is going to be 50 and our common difference is 5. So I feel like it's harder for us to kind of think about this unless you write out a few terms first. What we've really got going on here is a situation where we're starting at 50 and we're going down by 5 every time. And so we want to go add up the first 25 of these numbers that do this. Well, I suppose we're going to want to start with the fact that we want S25. And so with S25, we need to know three things here to find this sum. We need to know N, A1, and in this case, A25. So N25. A1 looks like we started with a value of 50, but what's the value of the 25th term? Hey, again, we're going to need to know the rule in order to find the value of the 25th term. So let's write our rule here. The value of the nth term would be the value of the first term, 50, plus the common difference, which is negative 5 times n minus 1. Let's go ahead and distribute here. We get 50 minus 5n plus 5. And so combining like terms, we have the value of any given term in the nth spot is negative 5n plus 55. So using our rule now, we can say, well, what is the value of our 25th term? A25 would be equal to negative 5 times 25 plus 55, which really is negative 125 plus 55. And I get from this, I suppose, negative 70. And so if this has a value of negative 70 here, put that negative there, then S25 is going to have a value of, start with n, which is the number of terms. We have 25 terms, times the average of the first and the last term in the series of numbers here. And so the very first term, we had a first term value of 50. We were able to determine that the 25th term would have a value of negative 70. So we'll put this in here. And this is over 2. We're going to average these. So really quickly here, let's take 25 times the average of 50 and negative 70. This would be negative 20 over 2, which makes that an average of negative 10. So if we multiply these, we get negative 250. It happens to be the case that if we were to add up the first 25 numbers in this sequence, it would actually be really negative, negative 250. And you might think, why does this happen? Well, it happens because eventually, if we keep subtracting 5 off of these numbers, we're going to start to go negative, and there must be way more negatives than positives in this series of numbers that we're adding up there. So in terms of finding arithmetic series, we just want to know this rule right here that says you can always find the sum of the first n terms by taking the number of terms times the average of the first and last term value. Cheers.